With our basic grasp of the Linux file system layout, let's go ahead and move on to talking about file permissions in Linux. So let's go back to our demo directory here and clean. So permissions in Linux break down into three types. There's the read permission, write permission, and execute permission. And there are also three categories or classifications of permissions. There's permissions for the user, permissions for the group, and permissions for those who are in neither category, or the other. To see permissions on files in Linux, you can use ls-l. This gives a long listing of the file. So if we do this, we'll see the permissions are listed here in the left columns. Now permissions have a special column here on the left that is used to indicate special properties of the file, such as if it's a directory or if it's a symbolic link. But past that are the columns that indicate the permission types. So here we have permissions that repeat every three. The first three permission columns indicate the permissions for the user, that is the owner of the file. The second three columns indicate the permissions for the group that the file belongs to. And the last three columns indicate the permissions for those users who are not in the group or not the user who owns the file. So here we can see that the user has read, write, and execute permissions for this file. The same goes for the group and for those who are neither the user nor in the group. We refer to those as simply the other. So here the CPU runner.py program has read, write, and execute permissions for the user, but only read and execute permissions for the group and for other. File 1 here, which is a text file, does not have the execution permission for any of the classifications, and it has write abilities or write permissions only for the user, the owner of the file. Over here in these columns, we can actually see the user and the group that the file belongs to. So here, for instance, my grocery list belongs to the user of UID of user identification Chris and of the group Chris. The remainder of these files are owned by the user Chris, but they are also belonging to the group users. So we can change and modify these permissions using a few simple commands. The first one we'll look at is the chmod command. This changes the mode of the file or the permission properties. It's fairly simple. You execute chmod using a letter to indicate the permission group or classification type that you would like to change, and the permissions that you would like to add or subtract to it. For instance, let's say I would like to remove the execute ability of CPU runner.py. I can do this for everybody by issuing a chmod A, which stands for all, minus, which means remove this type of permission, and X to mean the permission to execute. Then we issue the file name, CPU runner.py. Now if I do an ls-l CPU runner.py, we can see that I've dropped the execute permission from this file. Likewise, I can add it right back with a plus x CPU runner.py. And if we look at the permissions now, we can see that we've added the execute permission for everybody. What if I wanted to restrict this such that only I could execute this program. We run chmod u and g, or pardon me, chmod g and o. This stands for change the mode for group and for other, that is, those who are neither the user who owns the file nor in the group. And we can issue the -x for cprunner.py. Now, what if we wanted to have this file? Let's go ahead and take a look at what we've done. So now that we can see that the file is executable for the user, but not executable. It's read-only for anyone in the group or anyone who's outside of the group. So let's say we wanted to add back read and write permissions, or let's add write and execute permissions for the group. But let's add back only execute permissions for other. We can chmod group plus write x comma o to indicate other plus x cprunner.py. So we can separate the individual actions here with a comma. So let's go ahead and do that. And we can see that the program is now readable, writable, and executable by anyone in the users group now, in addition to the owner. And it's readable and executable by anyone who's not in the users group. To really see the effects of changing these permissions, however, I think we need the assistance of other users. So let's go ahead and log in as some other users. We'll get Wallace on here. And we'll also get Gromit here. Okay, so now we've got myself, Wallace, and Gromit all logged in to the same system. And let's have Wallace. Let's say Wallace would like to edit my CPU runner file, so he can do so by accessing my file. Here, we'll do it through my absolute path here. Demo CPU runner. So let's say he would like to make a change. So he brings up my file, and let's say he wants to change the comment here. So he can do this because he's in the users group. How do you tell what groups you're in is a good question, so let's see how to do that. If you type in the command ID and push enter, you'll get a listing of what your user's ID is, that is the number that represents your user, and then also the groups that you belong to. So here we can see he belongs to groups users and the group tinkerers. So since this CPU runner file is under group users, and I have given permission for the users, anyone in the group users, to be able to write to it, Wallace was able to edit my file. So we can verify this. So we can see that he's made this change here. Okay. Well, now what happens if we remove write abilities? So let's remove write abilities for the group from CPU runner and have Wallace attempt to do the same thing. we'll notice that I have a warning that this is a read-only file, so if I try and delete this word and save, read-only option is set. So even if I try and force save, I can't do it. So Wallace does not have the permissions to change this file anymore. However, he still has permissions to execute it, so if he were to issue the command to run this file, he would still be able to do that. Now, let's say I want to have only Wallace and myself, and Chris, the user Chris that is, be able to execute this file. Well, we can do that if Wallace and I happen to be in a group that no one else is. So let's check my groups. So I'm also in this Tinkerers group, and Wallace is in this group. However, if we check Gromit, he is not in the Tinkerers group. So I can change this CPU runner file to belong instead from the users group to the Tinkerers group with the command chgrp, or change group. We're going to change the group to Tinkerers for the file CPU runner. So let's do an ls-l. Sorry. So we can now see that this file belongs to the user Chris, but is now under the group Tinkerers. So let's go ahead and remove execute permission for others. That is, people who are not in the Tinkerers group and who are not Chris. And confirm this. So now this file is readable, writable, and executable by the user Chris, readable and executable for those in group, and only readable but not executable for those who are outside of the group Tinkerers. So I can execute this program. I can also write to it. So I have altered the file. Wallace can execute this program, and he can read it, oops, I'm sorry. He can read it, but he can't write to it. And Gromit should be able to do neither of those. So poor Gromit has permission denied from being able to run this program. And he can read it, but he also can't write to it. So that right there is the basic demonstration of how to change permissions on your files. It's pretty simple. You just have to play around with it for a bit and you'll get the hang of it.